Welcome to Summarize Science. There's a huge debate happening right now about AI. When we give models like ChatGPT extra training, are they really learning brand new skills, or are they just getting better at using tricks they already know? It's the difference between a student truly understanding calculus versus just getting faster at algebra. This paper tackles that question head-on, with some surprising results. To figure this out, researchers created a clean, controlled test environment to avoid any cheating. They defined a skill as the ability to perform a specific text transformation, like a simple code function. They first taught a large language model a set of simple, atomic skills, like removing duplicate letters from a word. The real test was whether the AI could then learn to solve a brand new, complex problem that required combining two of these simple skills, one after the other. This is called composition, and it's a cornerstone of how humans learn and solve problems. And here's their first major finding. Simply showing the AI examples of these complex problems wasn't enough to teach it. The key ingredient was reinforcement learning, or RL, which is a method of training that uses rewards and penalties, like training a pet. When they used RL on tasks that required combining skills, the AI suddenly unlocked a general ability to solve even harder problems which it had never seen in training. You can see in these charts how the models trained on compositional tasks, the orange and green lines, shoot up in performance on harder problems, while the model that only learned simple skills, in blue, completely flatlines. But here's where it gets really mind-blowing. This new skill was transferable. After learning the meta-skill of how to combine functions in the text game, the AI was able to apply that same logic to a completely different task, a math puzzle called Countdown. The model shown by the purple bar, which had both the basic math skills and the compositional training from the text game, dramatically outperformed all the others. This is huge because it suggests the AI didn't just memorize steps for one task, it learned an abstract strategy for problem solving. This finding also challenges a common criticism that RL just helps models re-rank or pick the best answer from a bunch of guesses. On the easy problems, seen on the left, the performance gap between the base model and the RL model shrinks as you give it more guesses, which fits that re-ranking story. But look at the hard problems on the right. Here, the performance gap actually gets wider. The RL model soars while the base model stays near zero. This is strong evidence that the AI has acquired a genuinely new skill, allowing it to solve problems that were previously impossible for it. The researchers also found that RL fundamentally changed the AI's reasoning process. Before this special training, the models would fail by simply ignoring that the problem had multiple steps. After training, the model correctly understood the multi-step structure, but might occasionally make a small error on one of the simple steps. This shows a shift from a high-level misunderstanding to a much more sophisticated approach. So let's recap the key takeaways. First, reinforcement learning can indeed teach AI models genuinely new skills, specifically the ability to compose simpler skills to solve complex problems. Second, this compositional skill is a generalizable meta-skill that can be transferred to totally new domains. And third, this proves that RL does more than just amplify existing abilities. It can expand a model's performance limits. This suggests a powerful future for AI development. Instead of trying to teach an AI everything at once, we could equip it with a library of basic skills and then use reinforcement learning to teach it how to combine them in creative ways to tackle novel, complex challenges. Thanks for watching Summarize Science.